Let's write a function that gives Mersenne primes. Okay, so it's 2n minus 1 where n is prime. So write def to define, or to start the definition. And then I'm going to call this Mersenne primes. And then the key here is that what you're actually inputting is going to be a prime number, not just any number. Then the colon, and I'll go ahead and define this one. So Mersenne equals, so you're taking 2 to the what number? Well, it's that prime input, and then subtracting 1. So it's basically 2 to the n minus 1 where n is prime, and then we want to return the Mersenne prime, which I've defined as Mersenne. Okay, so this will define it. Press Shift-Enter to run it. And this is a real kind of interesting mathematical topic. So Mersenne conjectured that this is a way potentially to generate primes. So let's test some of these. So the first prime is in fact 2. That's how you call the function. Press Shift-Enter, and you can see that you do get the answer of 3. So start typing again, and now it shows up here as an option, okay, in the list because it's been stored in Colab. So when it does that, you can go ahead and press return. Try the value of 3, the next prime, and we do get 7. Okay. I believe 5 is the next prime. We get 31, which is prime. And we can keep going. Okay. 7, is this going to be prime? You get 127. Now, how do we know if 127 is prime? There's some different ways you can check this. So I know that 1 plus 2 is 3, plus 7 is 10, because 3 does not divide 10, 3 does not divide 127. Certainly 2 doesn't because it's not even. Doesn't end in a 5. What about 7? Well, you can test this using Python, using 127 mod 7. And basically, if it divided it, we would get 0. There's a remainder of 1, so 7 does not divide it. 11 squared is 121, which would have a remainder of 6 left over. So this is, in fact, prime. You don't have to check prime numbers higher than that because they're going to exceed 127. So for instance, if 13 divided it, well, 13 times what? It would have to be a prime less than 13, and we've already checked all of those. So for the fun of it, we'll just do one more. Mersenne prime 11. And you quickly get a big number, 2047. So I can't say offhand whether that is prime. But I'll let you play around with this, check some more Mersenne primes, and see if you can find some that aren't prime. And I can tell you that regardless of that, Mersenne primes do play a big role in number theory because they have some other interesting properties.